All right, in lesson 5A, we're going to learn about how to present data using something called a stem and leaf plot. Stem and leaf plot retains your original data, or if you rounded the values, you might have rounded data values, but they don't convert everything into percents. Sometimes when we convert things into percents, we lose important information. Sometimes stem and leaf plots are also called stem plots, and they're based on the idea of place value. Here's an example of a stem and leaf plot. This is a 2013 Chevrolet passenger cars, pickups, SUVs. It's the highway miles per gallon for each of the different types of gas-powered vehicles. Let's go to the next slide. We'll look at some important information here. First of all, it says to find the key for the stem and leaf plot shown. Here's our key. So this represents 15 miles per gallon. This 6 represents a car that gets 16 miles per gallon. The stems represent which place value? This is the stem, and it represents the tens. Each leaf represents the ones place. So this leaf right here represents a gasoline miles per gallon of 33. You'll notice that there's a lot of some numbers and there's only a few of others. There's only one vehicle that gets 42 miles per gallon. There are a lot of vehicles that get 21. It says compare the number of 21s, the number with 2 in the tens place and 1 in the ones place, obvious, to the number of entries in the teens. Okay, if we look at the number of entries in the teens right here, we see there's 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 entries in the teens. And in particular, there's 8 entries from 15 to 19. If we look at the number that have 21 miles per gallon, it's this group. There's quite a few of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at 21 miles per gallon, we have 9 entries. If we wanted to compare them, we could say something along the lines of only in 2013, only 8 Chevrolet models of vehicles had, I don't want to say, gasoline usage that was in the teens, whereas there were 9 entries that got 21 miles per gallon or something. I'm not going to worry too much about writing sentences right now. This other type of stem and leaf plot is called a back-to-back plot. Notice now our stem is right here in the middle. We've got an 8 a.m. class, we've got an 11 a.m. class. Notice when we put them in order, we still have to be in order. We're going least to greatest this way and least to greatest this way. We can make quite a few comparisons like this. For one thing, look at this. In the 8 a.m. class, 1, 2, 3, 4, 5, 6, 7 students made A's, whereas no one in the 11 a.m. made an A. Obviously, this class stayed up late, but they weren't studying and they slept in. You could talk about ideas about the number of students who made 70 or better. You can see here you had 5 students with a 70 or better. But over here you have 1, 2, 3, 4, 5, 6, 7, 8. This row is 11. This row is 7. Whoops. That's 26. Whoa, I accidentally erased. Did not mean to do that. This is 5. But this has 26 that have 70 or better. Okay, so we get a lot of information if we want to look at it to actually compare. It says list the errors you see in the stem and leaf plot shown below. The most obvious error that I see is that the data is not in order. This row should read 0, 5, 9, least to greatest. This row should read 0, 3, 4, 5, 7, 9. This one's easier. This is 1, 3, 5, and this is 1, 2. I'm not going to do the other side. It's longer, except they should go least greatest with the least closest to the stem. So they go this way. This should be 1, 2, 4. This should start with the 0, 0. Then 2, 3, 5, 5, 9, 9. All right, so that's stem and leaf plots. We're going to move on to frequency tables and relative frequency. Same data we had, or similar data. This is the U.S. government tracks gas mileage by the size of the car. The table shown gives the highway gas mileage for 2013 cars in the mini compact size class. What information can you gain from a very quick glance at the table? Well, one of the things you probably notice, I see lots in the 30s. Whoops. Lots of higher mileage cars. Lots in the 20s too. I don't see much mileage in the teens. I also don't see any super high 40, but I see a lot of fairly high mileage cars, which I would expect if the car is really small. If we wanted to make a stem and leaf plot of the data, what's the very first thing we'd have to do? If I'm going to make a stem and leaf, the first thing I have to do is put the data in order. I'm not going to make the whole plot, they don't ask us to, but let's just at least think about it. We'd have our stem here, our leaf here. Notice the smallest value we see is 19. I see that 3 times. That looks like this. That's the only value in the teens that I see. Now I have to move on to data in the 20s. So when I start looking, the smallest that I see is 22. Let's change colors just so we don't get confused. So how many do I see? 1, 2, 3. Are there any more? I don't see any more. So we'd have 2, 2, 2. Our next, let's see. Do I see any with 23? No, but I see quite a few with 24. Let's see if we can find them. 1, 2, 3, 4. 25. Let me look one more time. I don't want to leave any out. It's going to throw my whole graph off if I do. So I see 1, 2, 3, 4, 5 that have a value of 24. Change color again just so I'm kind of fresh on what color. Let's do purple. There's 25, 25, let me see another 25. Don't think so. I think there's only, the purple was the 25, only 2 25s. And finally, let's just do 26. I think there's a lot of 26s. I think I'll circle those. There's 1, 2, 3, 4, 5, 6, 7. I don't think I missed any 26s. Takes a little time. So if there's 7, 1, 2, 3, 4, 5, 6, 7, I've got to put 6. 1, 2, 3, 4, 5, 6, 7 times. And you would just continue this process until all of your data was in the stem and leaf plot. Another type of table that we're going to look at is a frequency table. And basically the word frequency tells us, when I think of frequency, I think, how often does something happen? Or does something occur? That's what I think about when I think of frequency. Whoops. We're going to make a frequency table. To make a frequency table, the first thing you do is you take the range of data, which in this particular table, they've started the range here at 18 and the highest at 38. And you divide that data into groups. Those groups are called bins. In this example, each bin has 3 values. Your bins need to be the same size. So, the first bin is for the values 18, 19, and 20. I want to make a tally mark. Well, let's see. What do I have? There's 18, 19, or 20. We didn't have anything else in that group, so the tallies would be 3. That's a frequency of 3. If we want to get a different group, let's move to the next bin. We'll use, on a dark red, 21 to 23. Well, that's 21, 22, or 23. 21, 22, or 23. Again, that one also is a frequency of 3. What about 24 to 26? I think 24 to 26 is going to be a lot. So basically, every time you mark one out, you make a tick mark. So there's 1, 24. Oh, I didn't mark out the, hang on a minute. 20, I didn't mark out that 22. Okay, so 24, we put a tick mark. We want 24, 25, or 26. So let's just go across. There's 1, 2 more, so 2 more tick marks. Let's do this row. We already did that one. This row, 25, another tick mark. 24, another tick mark. So we've done 5. There's our crosshatch. 1, 2, 3, 4, 5. We're going to keep going. Tick marks. 1, 2, 3, 4, 5. So another 1, 2, 3, 4, 5. 1, 2, 3, 4. I got 14 that were either 24, 25, or 26. So let's just keep going. We're going to finish this table. Changing colors kind of helps me keep straight a little bit. So we want 27 to 29. I think also let's see, 27, 27, 28, or 29. There's 28. Whoops. 28. There's another 28. There's 2 27s. That's going to be 4, 5. Let's see how many more. 1, 2, 3, 4, 5, and 1, 2, 3. Let's double check we didn't miss anything that was 27, 28, or 29. I think I'm going to move to circles just for the variety. Let's go back to red. Let's do 30, 31, 32. 30, 31, 30. Oh, there's a 30. There's a 30. I don't think I see any 31s or any 32s. So I have 2. Oh, I didn't write down. Let me change my color back. I forgot to go ahead and say that was 13 tick marks there. 33 to 35. We'll do dark blue. 33 to 35. That's 33, 34, 35. There's 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Still looking for 33, 34, 35. There's 1, 2, 3. Let's look, make sure we didn't miss any. Every 33 or 34, 35 should be circled. That's 13. And finally, 36 to 38. Let's start. Is there any in this first row? Column? No. Any in the second column? No. Third column. There's 1, 2. And then over here we have a 37. That's 3. I think we put every single data point in one of our bins. All the data has been sorted into frequency tables. Looking at a frequency, you can tell that for these gas-powered mini compacts, it looks like we have a big peak right here. A big chunk of the cars are in that 24 to 29. But we have another peak up here around 33 to 35. Okay. Mini compacts that get 23 or less are pretty scarce, and mini compacts that get over 36 or more also seem to be scarce. Our third column was frequency. Well, we've already looked at the third column. We already completed that. It says check that the total of your frequency column equals the total number of data values. So let's go back and check that. What is the total? We might want to make a row down here. Let me see. For totals, let's just total it all up. That's 3 plus 3 plus 14, 13, 2. Okay, I need a calculator to make it quick and easy. That totals up to 51. I think that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 in the first three columns and only 12 in the last. So if you add up 13 plus 13 plus 13 plus 12, you get 51. So we know we have all of our data sorted into bins. All right. Now that we've done the frequency, we're going to go back and we're going to do something called, relative frequency. Okay, we don't need our tally marks. We know they've filled in all our data for us. Relative frequency is a percent. What part of the whole? So to get the relative frequency, we say what is 3 out of 51 is a percent. So we do 3 divided by 51 times 100%. If I do that, 3 divided by 51, I'm going to round this to the nearest tenth. The calculator actually gives me this number. But here's the tenths place. I look right next to it. Since this is more than 5, I have to round up. So relative frequency, 5.9%. 3 here is going to be exactly the same. So if I do 14 out of 51, 14 divided by 51 times 100, that's going to be 27.5. When I do 13 divided by 51, that's going to be 25.5. 2 divided by 51 is 3.9. We already did 13, that's 25.5. These are all percents. And 3, of course, was 5.9. Now, ideally, these should add up to be exactly 100. Once in a while, you may get 99.9 or 100.1 or 99.7 or 100.2 because of the rounding we have to do. We could be off by a tenth or so, but not too much. So if we add up 5.9 plus 5.9 plus 27.5 plus 25.5 plus 3.9 plus 25.5 plus 5.9, it added up this time to 100.1%. If you just want to say it's 100%, that's okay. Why should it be 100%? Well, because this should include all of the data. all of the data, 51 out of 51, should be 100%. And to the nearest whole number, it definitely is. It said, what should the total be? Well, we already said it should be 100%. And if we wanted to say why it should be 100%, it should be 100% because it represents the whole. Does relative frequency help you form a better understanding of the gas mileage of 2013 mini compact cars? Let's go back and look at it. I feel like relative frequency probably does. There's one more column that this PowerPoint doesn't include, but I know that it shows up on the homework, so I do want to look at that. And I'm going to have to erase a little bit of this first. Let's see, where's the eraser? Clean up a little workspace. The other thing we could talk about here would be cumulative frequency. Cumulative frequency is what happens if you want to know for all the way from 18 to 23. It's what you get if you add up. Well, cumulative frequency for 18 to 20 is 5.9%. But cumulative frequency for 18 to 23, I add these together. And if I add those together, I get 11.8%. So now we just keep adding. If I do 11.8 plus 27.5, this is going to be 39.3%. So that's about 40%, get anywhere from 18 to 26. If I add the 25.5, I get 64.8. You can make statements based on that say something like, approximately 65% of mini compact cars have gas mileage between 18 and 29 miles per gallon. It's just another way of thinking about it. If we add the 3.9, that's going to be 68.7 plus 25.5. That's 94.2. And of course, here's where we got our little bit of a rounding. When I add 5.9%, that came out to be 100.1%. 100% of the cars had gas mileage from 18 to 38. That's called a cumulative frequency, where you're just totaling up these. All right, it says there's no specific rule for bin size or the number of bins, but your choice of a bin size can affect how your data looks. So let's look what happens when we change the bin size. Create a new frequency table with the bins of size 10 as illustrated below. So if we use bins that are size 10 and we go 15 to 24, then 25 to 34, then 35 to 44, we're going to have much larger numbers. Let's go back and look at our data and find how many pieces of data are from 15 to 24. Thought we might do it here, but we can't. We'll have to go all the way back. I'm going to erase some of this so we can see it better. We're going to quickly jot this down. We're going to try to find all the data if we make the bins 3 sizes, and the first bin is 15 to 24. So 15 to 24, let's go through. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in the 15 to 24, I'm getting 11. In 25 to 34, let's pick a different color so we can kind of see those better. 25 to 34, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. About 32 in that mid-range. Whoa, something unexpected happened just then. There we go. And let's see. We'll go with red. We'll do 35 to 44. There's not going to be very many in 35 to 34. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. I only see 9. Let's make sure that adds up right, because I don't think it does. That adds up to 52. We counted something wrong. So we'll go back and count the reds again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think red is right. Let's go count the blacks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think it's right. So I think the error is the blue. Thought it probably was because it was the biggest group. So we'll change it. This was supposed to have been, it should have been a 31. And then we add all that up. That's 51. So 11, 31, and 9. Let's go fill in that table. $11, 31, 9. Oh, that should go here. Those aren't tally marks. That still adds up to 51. If I do relative frequency now, 11 divided by 51, it's going to be 21.6. 31 divided by 51 is going to be 60.8. And 9 divided by 51 is going to be 17.6. If we add that one up, 21.6 plus 60.8 plus 17.6, this time it did come out to be exactly 100%. We just didn't have a little rounding error. You can see it tells you that this is where the most of it all is. 60% fall right there in that range from 25 to 34. It doesn't give you quite as much precise data, but I think it just depends on your preference. Okay, that's where we're going to stop this video. Let me stop it.